Okay, everybody, so today we're going to be talking about the analyzing functions test. So as you guys can see, I have it screen recording. I'm pretty sure I do. Hold on, I'm going to show some. Oh, I guess I can't see the screen. Well, this will be fun. Hopefully you guys are I have the camera in the right position during this because I can't see it with the way I'm recording. Anyway, so I'm going to go over this entire review. So this is like what your test is going to look like. So the first couple questions here are asking for the domain and range of each of these functions. So again, domain is all your x values, right? So if I look at this graph, it's going left as it goes off the graph, and it's going right as it goes off the graph. So it's going those directions forever, because all I care about there are the x values on this line. So if it's going left forever, that means, and that's not an I, that's a colon there, just in case you're wondering. That means that it is going to negative infinity and a positive infinity, because it's going left forever and right forever. So basically you're looking to see if like the x values would ever stop at any point when you're doing domain, which it doesn't. They just keep going left and right forever. Range though, the y values, so again these are the x values, these are the y values. The y values do stop, right? Because that's these numbers on your y-axis, right? If we look at it, it bottoms out right here at -2. On the y-axis, right? It doesn't ever go below -2. It hits -2 and then it goes up from there. And it does go up forever, right? Both directions going up. Doesn't really matter. If it goes up forever one direction, then it's going up forever, right? So that means that your range, the least y value is -2, and the greatest y value would be positive infinity. Now you can never equal infinity, so it's a parenthesis, but it does hit -2. So -2 would have a bracket. Again, brackets just mean equal to. So brackets are equal, right? Parentheses are close, but not equal. Okay? So it gets really, really close. So close that instead of writing like, -2.000000000 whatever, right? I would put -2 in a parenthesis, but obviously it does equal -2, so bracket. And then I would do the same thing over here. Diagonal lines are like the easiest domain and ranges in the world because they have both horizontal and vertical aspects that are infinite, right? So if we look at this line, it's going left forever, it's going right forever. So the domain is -infinity to infinity. And range is going down forever, and it's going up forever. So -infinity to infinity. Okay? Because the y values are going down forever. Y values are going up forever. Infinity to infinity. Okay. Then, this next section wants me to write the intercepts of these functions. So like on my little Desmos thing, which we do have access to. Where's my cursor? We would just type in the equations. It's 2x plus 6. Okay, and we're just looking for the x and the y-intercept. So the x-intercept is -3, 0. So x-intercept is -3, 0. The y-intercept is 6, 0. Or 0, 6, sorry. 0, 6. 0, 6. Okay, that was really tough. Let's try to, you guys, you're so worried about this test, and it's not even tough. And then I get to the next thing and you're like, what? No, it's going to be fine. You guys are going to be fine. -3x minus 5. The x-intercept is -1.667. So the x is -1.667, comma 0. And the y-intercept, oh, why am I doing that? I want to just scroll down here. Okay, click on the line again. There we go. 0, -5. 0, -5. Okay. And then the next line would be x squared. So x caret 2. And then minus 2x. And then plus 5. There's my parabola. parabola. Everybody loves to say the word parabola, right? Now, does it have an x-axis? Doesn't look like it ever gets down to the x-axis. So the x-intercept would be none. There is no x-intercept, but the y-intercept, and there's only one, is at 0, 5. So 0, 5. Okay, that wasn't too tough. Now the next one wants me to combine all those things, so let's plug in our next equation. So this one wants me to do domain, range, intercepts, and the max or min. So negative x squared, and then minus x, and then plus 2. Okay, so first of all, domain. If we look at this, it is going left forever and it's going right forever as it goes off the graph, right? So the domain is going to be negative infinity to infinity. It's actually the case with most functions, is that it has an infinite domain. So usually domain will always be like negative infinity to infinity with like 95% of functions. So you have your square roots that don't have an infinite domain, but that's about, those are like the only ones that are real functions that don't have a domain. Okay, and then range is your y values, right? Now it's going down forever here, right? It's going down forever, but then it tops out at 2.25. So the domain is going to be negative infinity to 2.25. And it does hit 2.25, so we would put a bracket there. Okay. X-intercepts, it does have two of those at negative 2, 0 and at 1, 0. So negative 2, 0 and 1, 0. And it has one y-intercept at 0, 2. Okay. And then the max, so this one doesn't have a min, right? Because it's not bottoming out. It goes down forever. But it does have a max because it goes up and stops and then turns around. So that's basically what we're looking for with mins and max, is that point where it like stops and turns around, which you see on parabolas. Okay, so its max is at 2.25. Okay, 2.25, or technically you'd want the ordered pair, which is negative 0.5, 2.25. Okay, that's where it maxes out. That's its max spot. Okay. Okay. Then let's do another one. Same idea, but this time we take out the we put in the increasing, decreasing here. Okay. So we're gonna type in the new equation here. So we have a negative x squared minus, oh, it's the same equation. Why did I just, okay, anyway, it's the same thing. Okay, so increasing. Increasing is any time your line is going up from left to right. So it's going up all the way until we get to the max here, right? It stops at the max. So, and again, we just use the x values when we're talking about the intervals. So the x value here is negative 0.5, right? So it's increasing from negative infinity to negative 0.5. So increasing at negative infinity to negative 0.5. Okay? Now, it isn't actually increasing exactly at 0.5 because it stops and turns directions, right? So we would put a parenthesis there. And then it's the same idea with decreasing. It's going down from left to right, from negative 0.5 on to forever. So negative 0.5 on to infinity would be parentheses. Okay? Positive, again, we just use the x values, right? And that is the part of the line where it is above the x-axis, so the y values are positive. Okay? So if we look, it starts at negative 3 on the x-axis, it ends at 2 on the x-axis. Was this a different equation? Did I have different x-intercepts? Oh yeah, it was a different. Oh, there's a different plus minus number. Okay, so it was a different equation. Just had to change the 6 though. Okay, so it was negative 3 to positive 2. Okay, now on the number itself, y is 0, so it's not actually positive. So as soon as it gets to like 0.000000000000001 or whatever, you know, right, it becomes positive. So it gets infinitely close, so we'd use parentheses on those because it doesn't actually include the number itself, because 0 is neither negative or positive, right? It's nothing. It's not, we don't consider it positive, we don't consider it negative. It's neutral. It's the neutral number, okay? And then negative, there's two sections on here where it is negative, right? From negative infinity to -3, the line is below the x-axis, right? And from 2 to positive infinity, the line is below the x-axis. So we'd have two different interval notations. So negative infinity to -3, and again, parentheses. And there would be a u. I think I said not to use u's before, but I was wrong. That it is part of the same equation. I don't know why I was saying that. So 2 to infinity. Okay? And then constant, is it ever like completely flat? No, it isn't. So there's none are constant. Okay. Now, this next section. This is talking about the symmetry and describing which one is symmetry, like doing it algebraically. I don't care if you actually show it, because honestly it's very obvious in the equation itself if it is or not. And again, it's pretty obvious because the exponent tells you what it would be. Okay, so like this one, and again you could use Desmos as well to show you. If I did x squared, get rid of that, x squared and then -2. I mean, you can look at that and say, yeah, that's an even symmetry. I don't care, because again, even symmetry is symmetrical across the y-axis, right? So that means if I cut the graph and fold it over the y-axis, it should be symmetrical across the y-axis. Okay, and again, you can usually tell because the exponent in your equation is even, which is, you know, a pretty cool, you know, easy way to see. And again, like the idea to do it algebraically would be like if you replace the x with the negative x, you'd still get the same answer. So for example, if I plugged in a negative x, I'd have -x squared -2, which would then turn into x squared -2, right, when you squared it, which is the same as it started. So yeah. It's kind of a dumb thing to show, like algebraically, like especially if you can just graph it on Desmos, which you guys can. So, and again, I can just see it from the equation too that it's going to be even. Same with this one. It has an odd exponent. I know it's going to have an odd symmetry, assuming that it doesn't have a vertical or horizontal shift, right? So again, like if I just did -2x to the third, the thing that makes it odd is that I can like fold it across the origin or diagonally, right? If I fold this diagonally, it should fold onto itself. And I'm sitting here doing a hand motion over my screen showing that, but you guys can't see that, so that's not helpful. So again, like if you took this line and fold it diagonally, it would like fold on top of this line over here. Okay? But it just like right across the origin. Like right here, if I drew a diagonal line right here, like, and just folded it, it would fold onto itself there. Okay, so that's kind of the idea with that one. And then neither is not really symmetrical across the y-axis or the origin, which is what this would be. So if I did the absolute value, because there's a horizontal and vertical shift here, but if I did the absolute value of x -2, it's more the horizontal shift that messes this one up, and then a plus or -3. Okay, it's not like if this had been on the y-axis, like if it was like right here, like it would have been an even symmetry, but because of this horizontal shift, it's not symmetrical across the y-axis, and it's obviously not symmetrical across the origin. So that's a neither on that one. Okay, now the next section, end behavior, we're going to need our Desmos for. So when we look at end behavior, so this one we actually have a square root. So square root of x plus 4. So a horizontal shift. Now, end behavior is basically when x goes to negative infinity, x goes to positive infinity, right? Or basically it's whenever your x's stop. So this one actually has a little bit of a different end behavior, the square roots, because it doesn't go to negative infinity. So this is one of those domains that doesn't go to negative infinity, right? And when you're doing end behavior, you're just looking at the least of your domains and the highest of your domains. So basically, when we look at end behavior, and again, end behavior is like when x goes to negative infinity, right? And when x goes to positive infinity, what is your y value doing? That is only if like your end behavior or your domain is negative infinity to infinity. With this one, the least x value on here is negative 4. So for the end behavior here, I would have when x goes to negative of 4 and when x goes to infinity. So basically you need to find your domain because it's going to be the two things that your x is going to. And then you're just going to write what y goes to. Y goes to, when x is at negative 4, y is at 0, right? Y is at 0. It's where it starts. That's one end of your domain, right? End behavior is the end of your domain. So where your x starts, where do your y starts? When your x ends, where do your y ends, right? It's the end behavior on both ends of your line. And then when x goes to infinity, if we look at this line, it's kind of going up just shallowy forever. So if it's going up forever, that means y is going up forever, so it would also go to positive infinity. And again, end behavior can end in 3 spaces. It can go up forever to infinity, it can go flat, or it can like start at a point, at a number, right? Or it can go down forever to negative infinity. Those are like the 3 options with end behavior. Okay, that was the most confusing one. Let's try another one. So let's do number 14. So if I plug in negative, and again, I could do this without plugging it in because it's just going to be a diagonal line, which always has the same end behavior. You just got to figure out which direction. So again, domain of a diagonal line is negative infinity to infinity, right? So we're going to have when x goes to negative infinity and when x goes to positive infinity, y goes to, what does y go to? So when x goes to negative infinity, so that's to the left, right? So as we're going left, is the line going up, flat, or down? Well, if we go left, it looks like it's going up, right? It's going up forever. So that means it's going to positive infinity. And then as we go right, it's going down. So that means it's going to negative infinity. Okay? Not too tough. Let's try one more. Again, this one, it's going to be a parabola. But I already know that parabolas have a negative infinity to infinity domain because they always go left and right forever. So as x goes to negative infinity, as x goes to positive infinity, y goes to what? Okay, so when I look at, why am I going there? I'm going to type in the equation. So 2x squared, and then plus 4x, oops, not equals 4x, plus 4x, and then minus 5. Okay, there's my parabolas. So as x goes to negative infinity, the line is going up forever. So as we go left, the line is going up, which means positive infinity. And then as we go right, my line is also going up, which also means it's going to positive infinity. So both directions, it's going to up to positive infinity, which makes sense if it's a U, right? Parabolas either go up forever or down forever, depending on if it's a upside down or normal right side up parabola. Okay. Now, this next section, the average rate of change, there's 2 ways you can do it. It seemed like some of you guys are getting confused on the graphs, but I'm going to show you on the graph real quick how I would do it. And then I'll also do it by hand. Some of you guys seem to like that one better, but I mean, it's still going to get you the same answer. So if I do x squared, and then minus 2x, and then plus 4. Okay, so here's my parabola. there it is. Okay, so it wants me to figure out the average rate of change between 0 and 4 on the x-axis. Okay, so I can see right here that it hits 4, or hits 4 at 0, right? And then on 4, it's up here at positive 12. Okay, so it's up here for 12. So that means that from here to here, and I can't draw a line on here, I think, although that would be nice if I could draw a line from there to there. That would be the slope that I'm looking for. But I can do a couple things. I know that it goes from 4 to 12, which is a difference of 8, right? So it's going up 8, and it's going over 4. So my slope, or my average rate of change, is 8 over 4, which just simplifies to 2. Okay? Now, again, I can find that mathematically by making a table. So if I do a table, plug in these are my x values, 0 and 4, and then I plug them into my equation here. So 0 squared minus 2 times 0, and then plus 4. That'd be 0 minus 0 plus 4, which is 4, right? Okay, and then if I do the same thing with 4, so 4 squared minus 2 times 4 plus 4. So 4 squared is 16, and then if I minus 2 times 4 is 8, so 16 minus 8 is 8, and then plus 4 is 12, okay? Which should be familiar numbers, because those are basically the 2 points that I clicked on Desmos. And then you just figure out the difference between the y, which is going up 8, and the difference in the x is going up 4, so it would be 8 over 4, which you would write as 2. Okay? So either way, you could look on Desmos, you could do it mathematically. It's not hard either way. It's just finding the slope, right? That's all we're doing. Okay? Let's try another one. Let's do it on Desmos, and I'll do it mathematically again just to show you, okay? So let's say I have negative x squared, and then plus 6x, and then minus 10. Okay. Now, I would love if it would just scroll instead of zooming in and out, but I get it. Okay, anyway. So negative 2 on the x to 3 on the x is the range that it gives me. So negative 2 is right here, right? So all the way down right here. Negative 1 and negative 17. That's not even negative 2. So all the way down here is going to be negative 26. So we have negative 26 at negative 2, and then 3 is up here at negative 1. So it goes from negative 26 to negative 1, so that's going up 25 over 5. So again, 25 over 5 would simplify to just 5 as my answer. Now let's see if I do it by hand, if I get the same thing. So x, y, negative 2, and 3. And then if I plug negative 2 in, it'd have negative 2 squared minus 6, or not minus, plus 6 times negative 2, and then minus 10. Okay, so negative 2 squared is 4, and then it becomes negative. 6 times negative 2 is negative 12, so I have negative 4, minus 12 is negative 16, yeah, and then minus 10 is negative 26. Which is the point that I got, negative 2, negative 26. And then I would do the same thing, so negative 3 squared plus 6 times 3 minus 10. So 3 squared is 9, becomes negative, and then 6 times 3 is 18, and then I would minus 9, which would become 9, and then 9 minus 10 is negative 1. And then if I do the difference, it's plus 25, and then the difference is plus 5, which is, again, what I got from the graph. And then I'm going to just do it, and you would get 5, right? This time it gives me a table. Wants me to find an average rate of change from 0 to 2 seconds. So again, 0 to 2 is this range, right? So that difference is 2. Okay, and then it goes from 200 to 50, which is a negative 50. So the average rate of change would be negative 50 over 2, which is just negative 25. That was a pretty tough one. Okay, so yeah, the unit was a little bit confusing. Yeah, like I was gone for a little bit, and yeah, the quizzes were a little mess, but this shouldn't be too tough of a test. Just a little bit of things to remember. Okay, so if you have any questions, make sure you ask them. I'm always here to help, and I'll see you guys out there. Okay? Alright, I'm gonna turn this off. Control F10. Maybe? No? Okay, well, I'm just gonna click stop.